This short video is covering the naming of acids and also reviewing the naming of bases. The naming of bases would be very similar to the naming that you did last semester in your Chemistry 1 class. Okay, naming acids. So step one, you need to identify, is it a binary acid or is it an oxyacid? If it is a binary acid, right, it says acids which contain hydrogen and another element. The key here is that it's only going to have one other element. And an oxyacid, it's going to have oxygen and another element. So pretty much if you see hydrogen as the first element and then you see only one other element, it is a binary acid. If you see hydrogen with other elements plus oxygen, then it's an oxyacid. So we are going to first deal with binary acids. And it says, identify the name of the anion, right, the negatively charged ion, with "ide" ending, which basically is the second element, right? We have chloride and we have sulfide. Normally we would say that name is hydrogen chloride or hydrogen sulfide, but because it's an acid, we're going to name it differently. So instead of taking this ending of "ide," we are going to drop it and we're going to add "ic" to it. Now, before we do that though, we're going to put hydro in front of the anion name, which is always going to be our hydrogen. So we want, not in front of the hydrogen, in front of the anion, in front of the second element, right? So we have, whoops, can't spell, we have hydro, right? And then it's chloride. We're not going to say it's chloride. We're going to say it's chloric, changing to that "ic" ending. It's all one word. And then after that, you just put acid, right? Which it states here in our second rule. So our H2S, right? It's binary because there's only two elements. So that means it's going to start with hydro. Instead of sulfide, it's going to be sulfic, and add our second word, acid, at the end. Now, as far as our bases go, well, in order to name the bases, it's just like any normal naming of a particle, right? We have our OH is a polyatomic ion, and so naming something with a polyatomic ion is very simple. You write out the first element, right? So potassium, and then OH is hydroxide. That's easy enough, right? We have sodium and hydroxide. Okay, let's move to our oxyacids. So with an oxyacid, right, we are going to figure out the name of the polyatomic ion that is bonded to our hydrogen. So SO4 has the name of sulfate. Okay, then using our step 2, if it ends in 8, we're going to change it to "ic." So it is sulfate, right? So we're going to change it to sulfic. And then where we go? And then we are adding acid at the end. So notice that there's no hydro in front. So now it's not hydrosulfic, it's just sulfic and then acid at the end. Looking at our next example, ClO4 is chlorite. It ends in "ite," and so if we're looking at our step 2b, right, "ite" changes to OUS. So now, right, we have CHLOR instead of "ite," it's OUS, and add in our acid. And naming is that simple. Let's see what we got next here. Formula writing from acids. So if you have the name of the acid, you're also going to have to be able to go and write the formula for the acid. So let's take a look at our rules here. right? We know if it's a binary acid, it's going to start with hydro. And if it doesn't start with hydro, that means it's an oxyacid, which means there's a polyatomic ion in there. So, first thing we know, right, looking at our first example, hydrobromic acid. Well, it says hydro, so we know that it is a binary acid, so it's only made up of two elements. We know it's made up of hydrogen, of course, and then bromic would be bromide, which is right from the periodic table bromine. Now, we need to look for our charges, and we're going to use this crisscross method if you are familiar with it. Looking at your periodic table, you'll see that the most likely charge of hydrogen is +1. Bromine would be -1. So therefore, when you crisscross it, right, it tells you the subscript of the opposite element. So it would be H1Br1. Well, of course, if it's 1, you don't put a subscript, so it's just HBr. Let's look at our next one, right? Binary, because it's hydro. We have sulfuric, which is sulfide. So we have hydrogen, which is +1. We have sulfur, which is -2. So using our crisscross, right, we know that we would have H2 and S1. Well, again, of course, we don't put in the ones, so it's just H2S. Let's look at some oxyacids, right? Notice that there is no, these are bases. So magnesium hydroxide, right? We have magnesium and hydroxide. Remember, hydroxide is -1 and magnesium is +2. So using our crisscross method, right, we get Mg1, so we leave that off, and then we get OH2. Now remember, if you write it like that, that means you have one oxygen and two hydrogens, so it has to be in parentheses, right? You get MgOH2. And our last one, right, lithium, and lithium has a charge of +1. Again, hydroxide is -1. So using our crisscross, we get LiOH. There's no need for parentheses because there is only one hydroxide in there. Okay, formula writing from acids. Now we are focused on our oxyacids, and again, we are moving backwards. So sulfuric acid, right, there's no hydro in front of the word, so therefore it is going to end with a polyatomic ion. So remember that if it's ic, right, it was 8. So if we have sulfuric, right, that means we need to end in 8, right? And sulfate, if you look at your polyatomic sheet, is SO4, and it has a charge of -2. And of course, it's an acid, which means there's also hydrogen that has a charge of +1. So using our crisscross, right, we know that our 1 is going to go here, and our 2 is going to go here. You get H2SO4 is the proper formula. Our last one, bromous, it is ending in OUS, and so if you look at our rules, right, if it ends in OUS, it's going to, the polyatomic is going to be an ite, so we know we have hydrogen, of course, and then bromous is going to be bromite. Looking at your polyatomic ion sheet, bromite is BrO2 with a charge of -1. Hydrogen, of course, is +1. So crisscrossing, you just get HBrO2. I hope this was helpful in naming and writing formulas for acids, and a quick review of how to write and name bases.